Find the volume of the solid formed by revolving the region bounded by the graph of f of x equals the square root of sine x and the x-axis from 0 to pi about the x-axis. Okay, so what we have to think about doing here is we're taking a slice right here of this, and we're going to revolve that around the x-axis here to make a circle, right? So this piece right here, what we've been calling a lot of times our S for the other problems, this is going to be the radius of all of those circles that are created whenever you rotate it. So we're going to call that R of S or R of X because this one is in terms of X. Yes, that red line right there, this red line right here is R of X. So that is just going to be top function minus bottom function. But for the ones that you're going to see today, that bottom function is going to always be 0. We're going to see ones that are different later, but right now that should always be 0. So the top equation is the square root of sine minus x, or not sine minus x, square root of sine x. And then the bottom equation would just be 0, so you don't really have to write that. So we would be using the formula pi r squared. You can put the pi on the inside or the outside of the integral. The formula didn't have it there. I almost would suggest putting it on the inside of the integral, at least to begin with. And the reason that I say that is because it's just really easy to forget to put the pi in there at all. So we would integrate from 0 to pi. Since this is in terms of x, we look at the x-axis for our limits. They told us this was from 0 to pi, so that's how we know that this stops right here at pi. If it didn't tell us that, we'd have to solve it. So to integrate this, it's not going to be too bad actually, because I could pull the pi out front if I want. What happens when I square the square root? It goes away. I've just got sine x dx. And what do I get when I integrate sine x? Negative cosine. And then out here we would have pi. And so we would have pi times negative cosine of pi minus negative cosine of 0. Oh, unit circle. Pi negative 1, 0. So that'd be negative 1. We'll go ahead and change this to a plus. What's cosine of 0? 1. So negative 1 is positive 1. 1 plus 1 is 2. So we get 2 pi. We have to rotate around different axes, which is not, we're not doing that today, which makes it a little tougher. Sometimes there will be a hole in the middle of whatever we're integrating. So like we'll have a top function and a bottom function, which will make it harder to integrate, but it's still the same idea, really. So it does get a little bit more difficult, but if you understand the concept for this one, it's just going to be expanded a little bit. Okay, it's similar to what we're doing, but what we were labeling S and we were building like a piece off of that is now our radius there. And we're rotating that around. Okay, questions?
So 2 pi is the area
It's the volume.
volume of the shape.
Yeah, so this like football shape we're going to get whenever we rotate that is going to have a volume of 2 pi. Okay. For example 2, we're supposed to find the volume of the solid formed by revolving the region bounded by the graph of x to the third plus 1, y equals 0, x equals 2 around the x-axis. So I'm going to graph my y equals 0 and x equals 2 first, just because they're easier. Y equals 0, which axis is that? That is our x-axis. X equals 2. It is a vertical line at 2. It does not. Yes. Yes. Yep. What helps me to remember that, because it's really easy to get those mixed up, I think about what the points are on that line. So like the points here, the coordinates here would be 2, 4. This like coordinates here would be 2, 3. Right here you got 2, 0. So all the x coordinates are 0 on that line. Yeah. All right. And so x to the third plus 1, it's the, x, it's the cubic shape, that squiggle there. So you can also just plug in numbers. So 0 squared, 0 cubed plus 1 is going to give you 1. 1 cubed plus 1 will give you 2. And then 2 cubed plus 1, oh, my graph is bad, isn't it? Because 2 cubed is going to be 8 plus 1. I need this to go up to 9. So it's going to be like up here. We can get the idea of what we need from this. So they're going to cross up here. We're going to call this right here 9. Yeah, I need to go back and fix that graph.
Like the 9 is actually about 6.
Yeah, it's not good. It's a bad graph. But I think it's going to give us the general idea of what we need, at least. So we are taking this area and we are going to revolve it. So we're around the x-axis. So it's like we're taking a slice here. And you're going to revolve that around to make all these circles. What's it going to look like? It could be a hat, but it'll have a flat top, right? It's going to be like a plateau sort of shape, just sideways.
It's anvil, upside down anvil.
I don't know. Because it's going to be the same on both sides. Yeah.
Oh, wait. No, yeah. It'll be like a table. Yeah.
Yeah, could be a table. All right. So, it'll be flat on this side right here. And on the bottom part right there. Whichever one you want. Yeah. Okay, so whenever you're rotating around the axis, your equation is always pi r squared. Okay? But you have to get an equation for your r. Okay? So in this case, it's top minus bottom. which the bottom is just 0, which is going to be the case for today. So we just get x to the third plus 1 is our radius. So our equation that we want to integrate is going to be pi times that x to the third plus 1 squared. We need to integrate that. What should our limits on our integral be? 0 to 2. It does because it tells you first quadrant. So first quadrant means you're going to stop whenever you get to that y-axis. It also gives you a boundary of that x equals 2 line. There. Oh, should we assume it's first quadrant? I was reading that it was first quadrant, but it does not say first quadrant anywhere, does it? Ugh. Y equals 0 tells us we're going to use that as our bottom line. But we really do need to add this piece right here. If I plugged in -1, I would get 0. So, I'm glad that you asked that question. So it did not say first quadrant. If it said first quadrant, you would stop there. But it did not say that, so we do need to do this. But that's not going to change much about what we have here. What's the only thing that's going to change? We should go from -1 to 2 instead of 0 to 2. I was just plugging in numbers that would work here. So if they're going to give you one where they don't give you a graph or the calculator, they'll probably give you something fairly simple where if you plug in numbers, you'll get numbers that you can graph easily. So I was just testing numbers that would plug in, and I happened to get 0 here. If you did not get 0, then it would be much more difficult. But usually if that's the case, they'll either give you a picture of the graph or they'll let you use the calculator. It's just the area of a circle because when you rotate here, it's going to make all those circles. So it's always going to be pi r squared for these. Yes. Okay. All right. So, so we need to integrate this. We'll pull the pi out front. We're going to have to square that out first. So we will get x to the 6th plus 2x cubed plus 1 dx. And keep that pi out there. We're going to get 1/7 x to the 7th plus 1/2 x to the 4th plus x. And we will evaluate that from -1 to 2. And I don't think they would ask you to do this without a calculator. So I'm going to let us cheat and just type it into the calculator. Oh, let me do this a piece at a time. I'm going to mess that up. Daniel, you're doing it without the calculator. See if you can do it faster than I can type it in. I think it's possible. Oh, wait. I put a 7 where I should have put a 2 right there. 2 to the 7th, to the 4th, to... I mean, it'd be easier to integrate this, honestly, than to do this, but... and then we'll have... You could do it either way. It would be fine.
What? Oh, dude, that's just some elite jokes. Who are you gonna pet? You're gonna be sad. You'll be petting. How are you gonna recover?
So you would have this, or if you want to do decimal, 90.8818. The biggest emphasis on this is getting them set up correctly. A lot of times on these, they don't even ask you to actually integrate. They ask you, they'll say set up, but do not integrate. Yeah. 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 Okay, questions? Yes.
But it'll be on the exam.
Yes, it will be on our exam, yes. Because Calculus AB covers all of Calc 1 and a little bit of Calc 2. So that if you pass it, you don't start off in Calc 2 lost.
So then how come we need it for the AP exam? Why is it on the AP exam?
Because they don't want to give you AP credit. So the point of the AP exam is to tell colleges that you are ready to take Calc 2. And so if all they put on the exam was Calc 1, you might halfway know it, but you might not really be ready for Calc 2. So I think it is wise that they do it the way they do it.
Is it different for college? So like if I go take Calc 1, I won't be doing this when I do Calc 2.
You probably would not do this in Calc 1. This would probably be the beginning of Calc 2. But a lot of times in college, like, there won't be review at the beginning of the course. So you would, like, whereas here we might review things that you did in Math 3 and Pre-Cal and so on. There's not usually a lot of review of the prior course at the beginning of that course. So that's why I think it is a good thing that AP decided to put part of Calc 2 here, so that you're not seeing brand new stuff with no review your first year in college and having really difficult stuff. So. We have an FRQ on Friday. The test will be next week.
Yesterday we learned everything we need to know for the FRQ.
On the FRQ, test corrections are due for Unit 7. So Friday, FRQ quiz and test corrections for Unit 7 are due. I'll look here in a second. Yeah, on your FRQ could have another one, but I'll probably stick to cross sections for that since this is fairly new. Because the only ones that you have on your on the 3 that I gave you are cross sections, so I'll probably stick to cross sections on this. All right, last one. Find the volume of the solid formed by revolving the region bounded by the graph of y equals x squared, x equals 0, and y equals 8 in the first quadrant around the y-axis. So I like to start off with those straight lines. X equals 0, what is that? It is the y-axis here. Y equals 8. Horizontal line at 8. And then I got to do y equals 2x squared. So 2 times 0 squared is 0. 2 times 1 squared is 2. 2 times 2 squared would be 8. So we'll get, does it say first quadrant? It does say first quadrant this time. So we're looking at first quadrant here. So it's this area that we're looking at. So this time we're revolving around the y-axis. So when I see that I'm revolving around the y-axis, that tells me that I'm solving this in terms of y, which means this equation right here needs to be solved for our y. So we could divide by 2. Y over 2 would equal x squared. We would square root both sides. So x would equal plus or minus the square root of y over 2. And which side is it going to be, the positive or negative? It's going to be positive because we're on the right side. So we'll have x equals positive square root of y over 2. Okay, so that is my blue graph that I have here. So I'm going to take here a slice, this time perpendicular to that y-axis. I'm going to revolve it around this. And so you're going to get something that looks sort of like a champagne glass or something there without the stem, the missile maybe there. And so whenever you rotate this, your radius, I'm going to call it r of y this time because we're in terms of y. It's just right minus left. Today, the left is always going to be 0. So it's just square root of y over 2 is our radius here. So we need to integrate pi times that radius squared. What should our limits on this be? 0 to 8. Very good. We look at the y-axis for those limits. So I'm going to pull the pi out front. And when I square the square root, I just get y over 2, or I'm going to write that as 1/2 times y. I think it makes it easier. Probably y right there. To integrate. So when we integrate 1/2 y, we're going to increase our exponent by 1, so it'll give us y squared. We divide by 2. So what is 1/2 divided by 2? 1/4. And we will evaluate this from 0 to 8. So this one is not too bad to do. We're just going to have 1/4 times 8 squared minus 1/4 times 0 squared. So that's going to be pi and 1/4 of 64/16. So we get 16 pi for our answer. Okay. So let me look at this homework and make sure. I looked at it the other day. All right. We're good there. 1, 3, 7, 9, 13A, 14B, 25, and 33. So for these problems, several of them give you a picture, so you won't even have to worry about graphing them. But for these, I want you to make sure that you write down your setup for these. Many of these you should be able to solve by hand, but I will allow you to use your calculator because the emphasis here is really on being able to set these up correctly. I would also like you to be able to solve them, but I realize that sometimes it can take 5 or 6 minutes just to solve that out by hand at the end. So make sure you write down what you set up, but you may use the calculator to integrate on these if you find it helpful.